Okay, everyone. So we are going to start the detailing about sodium hydrogen carbonate, which is nothing but the sodium bicarbonate. It is also called as baking soda or baking powder. Okay, so sodium hydrogen carbonate is also known as sodium carbonate or baking soda because it decomposes on heating to generate bubbles of carbon dioxide gas, okay, and which leave the pore on the cake, okay, even in pastries, bread, etc., and makes it light and fluffy. You know that, right? It's like spongy, you can say spongy due to releasing the carbon dioxide gas, where gas is going to release from there, it makes the holes and pores in that dough, right? And it becomes very puffy, and we used to eat that. It is very nutritious also, right? That bread we are eating? Yes. Okay. So here we have NaHCO3. When we are going to heat that beta, okay, when we will heat that, it gives carbon dioxide gas CO2 and gives NaOH, sodium hydroxide. Okay, so this is the first product and this is the second. That carbon dioxide is releasing from there. Okay, next, and you know that sodium hydroxide, if we will eat that, it neutralizes the acid HCl present in our stomach and gives NaCl plus H2O. Right? So that acid present in our stomach, it is secreted by the gastric gland present in our stomach and it used to neutralize the acid. Okay, that sodium chloride formed in our stomach gives or like react with HCl present in our stomach and form the chloride and water. Means it is neutralization reaction. So whatever the acid present in our stomach get neutralized. Okay.
Yes, sir.
Okay, beta. Yes. Now we have to understand how sodium hydrogen carbonate is going to prepare. So sodium bicarbonate is made by saturating the solution of sodium carbonate with the carbon dioxide. Okay. So on sodium carbonate, we had to like saturate with the carbon dioxide gas the white crystalline powder of sodium hydrogen carbonate, which is less soluble and gets separated. Okay, so here we have sodium carbonate. We are like supplying carbon dioxide with water, gives sodium hydrogen carbonate. Here we have to multiply it by 2. Now the reaction is balanced. Okay, so this is the way how sodium hydrogen carbonate is formed. Okay, everyone. Okay, and I think I got one question from who has given that question? Dhananjay.
Yes, sir.
Yes. So the gas which is releases that particular time, you send that question, no? It is carbon dioxide gas beta, and which is colorless and odorless.
Okay, you write the reaction.
Yeah. Can you read the question? Wait, I'm just moving the screen. Yes. Can you read the question for me?
Yes, sir.
Yeah.
On adding acetic acid on dry
Acetic
hydrogen
acid. Wait. Acetic acid formula CH3COOH. Someone is in waiting room. Wait a second. Yes. Nityasri, OMG. Now she is in Canada. Nityasri, good evening, beta.
Good evening, sir.
Have you reached Canada?
Yes, sir.
Okay, very good. So how
Thank
is
you.
weather there?
It's changing, sir, from day to day. It's like sunny a day and then it's too rainy, it's too cold.
Okay.
Sir, which lesson are you saying?
What, beta?
Which lesson are you teaching, sir?
acid, base, and salt.
Okay.
Okay. So this is the acetic acid beta. Yes. After that,
On adding acetic acid
uh,
to hydrogen carbon, solid hydrogen carbon.
after that,
A student observes the liberation of
what is the name of that powder beta?
solid hydrogen carbonate.
Okay, hydrogen carbonate. Solid hydrogen carbonate.
Yes.
I think it is sodium hydrogen carbonate, NaHCO3.
Bicarbonate.
Yes, it is NaHCO3 beta. Okay. So see, here it is acidic, here it is basic in nature. So they will give see one more like important point I'm going to explain here. Whenever we are having the carbonate reactant, our one product is always fixed beta. And
Carbon
which is
dioxide.
yes, carbon dioxide. We already gone through that, right? Okay. Now here, see, we have sodium beta, sodium, right? And here that part it's going to form sodium acetate. Sodium acetate means CH3 COONA, and it is a salt. So it is sodium acetate. Sodium acetate. Okay, carbon dioxide, and see here we have one hydrogen, from here one oxygen, and here one hydrogen. So two hydrogen and one oxygen. What they will form? H2O. So we gonna have
H2O.
H2O here. Yes. So now this is the reaction beta for your question. Okay.
Okay, sir.
Yes. So let me erase. Okay. So what are the options? I think which gas is going to release, right? So gas is, see, carbon dioxide is colorless, and there is no odor, so it is odorless. So it is colorless and odorless gas.
Okay, sir.
Yes. Any doubt?
No.
Okay. Next. You can take a screenshot. Done?
Yes, sir.
Okay. Okay. So on addition, okay, on an industrial scale, sodium hydrogen carbonate is obtained in an intermediate product. Intermediate product beta means
In middle only it will be like one of the
chemical it will form during the solvent process for the manufacturing of sodium carbonate. So in solvent process, sodium hydrogen carbonate is being intermediate product. Okay. Yes.
it is
No,
required
now-
from sodium carbonate.
Yes, yes. Okay, next, its properties. Sodium hydrogen carbonate is a white crystalline solid having a density of about 2.2 gram per milliliter. Okay, it is alkaline, means it is basic in nature, alkaline test, and the strongly soluble in water. So it is again soluble in water. And solubility of the sodium hydrogen carbonate increases with increase in temperature. As temperature increases, solubility of sodium bicarbonate is also increases. Right? So it is directly proportional. Like solubility of sodium carbonate in water is directly proportional to the temperature. Easy?
Yes, sir.
Yes.
So what is
Now,
sparingly soluble?
means easily soluble, like salt, if you will dissolve in water, so it will dissolve easily, no?
Yes.
Like this, yes. Okay, now we have uses. As component of the baking powder, okay, so in baking powder, okay, it is the main component of baking powder. Next, it is used in fire extinguisher. So in fire extinguisher, we have NaHCO3 plus there we are using H2SO4 sulfuric acid Then when they react, so they form carbon dioxide, then sodium sulfate, Na2SO4 and water. Yes. Okay. In order to balance reaction, we have to multiply here 2 sodium sulfate. Okay. Then H2O. Twice H2O. Now the reaction is balanced. So they form sodium sulfate, water, and carbon dioxide. And that carbon dioxide produced in a very large amount used to extinguish the fire. Okay. So these are the material present on fire extinguisher beta. Okay, everyone. In medicine, a mild antiseptic for skin disease and neutralize the acidity of the stomach, like powder. We are using baking powder, means sodium hydrogen carbonate, and as a reagent in laboratory. So in laboratory for many chemical reactions, we are using that sodium hydrogen carbonate as a reagent. Beta. Reagent. Okay, everyone.
Yes, sir.
Yes. So any doubt beta here? Repeat it once.
Sir, can you explain what's a reagent, sir?
Reagent means in many chemical reaction, the medium is required in order to proceed the reaction in forward direction beta. They are called as reagent. Means it can be used as a out of 2 or more reactant, it can be used as a first reaction or one reactant, which is called as reagent. Okay.
Yes, sir.
Yeah.
So for what type of reactions is it a reagent for, sir?
Many, you can say even in neutralization reaction also. There are many reactions beta. They can be used as a reagent. It is nothing but a substrate, or it can be the medium in order to proceed the direction in forward direction. It provides the medium beta, medium.
Yes, sir.
Now any doubt? Everyone, any doubt beta?
No, sir.
Oh.
No, sir.
Now we have sodium hydroxide. It is the base. Okay. Okay. See, sodium hydroxide is also called as beta caustic soda. So these are the common name you have to remember. Why it is called as caustic soda? Because it is a corrosive in nature. It may cause corrosion. Okay. Action on animals and vegetables tissue. So it used to destroy the animal and plant tissue better. Okay, that's why it is called as caustic soda. So just whenever you are going to use that chemical in laboratory, just take care proper. Okay, proper precautions should be taken while using these chemicals in laboratory. Okay, large quantity of sodium hydroxide is prepared by electrolytic process called chloralkali process. Okay, here sodium hydroxide is being formed by the electrolysis process of sodium, chloride, NaCl. Sodium chloride, when reacts with water in electrolysis process, gives chlorine gas is going to release and NaOH. NaOH is going to form like this. Okay, and chlorine gas will release. Okay, everyone.
Yes, sir.
Yes. So this is nothing but the electrolysis product of electrolysis process of aqueous NaCl. Okay, here chlorine gas is given. See, chlorine gas is given out on the anode, and hydrogen gas is at cathode. So hydrogen gas is again going to release. Okay, but when water going to break water, so here we can write twice, and here we can write H2 also. Okay, so now we had 2 oxygen, hydrogen 4, 2 in the form of gas, and 2 H. Yes, now reaction is balanced. Okay, so see, hydrogen and chlorine gas are going to liberate, and the product, the main product that we are going to form, which is sodium hydroxide. Sodium hydroxide solution is formed near the cathode. So it is formed at cathode. Easy? The preparation?
Yes, sir.
Yes. So you can like take a screenshot, you will have that reaction also. Done?
Yes, sir.
Okay. Now its properties. Sodium hydroxide is a white deliquescent solid having melting point 591 Kelvin, means 318 Kelvin. Beta. What is the meaning of deliquescent? Who will tell? Nityasri?
Yes, sir.
What is the meaning of deliquescent? Deliquescent.
Okay.
Sir, is it
I don't
soft?
know, sir.
Huh?
I don't know, sir.
It's like any
Is
substance.
it soft solid, sir?
Like substance they used to absorb moisture from the surrounding and convert into liquid form. Beta.
Okay.
Yes, see, deliquescent solid. So it is hygroscopic, you can say hygroscopic. It will absorb surroundings moisture and turn into liquid form. Okay.
Okay, sir.
Okay. Liquid form means in a solution form. Beta. Solution form. It is not the melted form. It is a solution form. You can see. Okay. It
Okay.
is the stable toward the heat. Okay. So see, temperature is like its melting point is very high. It is 318 degrees Celsius, and it is quite high, right? That's why it shows thermal stability up to 300 degrees Celsius. Okay. It is highly soluble in water, and considerable amount of heat is evolved due to the formation of number of hydrates. Okay, means see, it's present in the form of NaOH dot H2O, then NaOH dot twice H2O. So it may contain n number of water molecules as a crystalline water, you can say, water of crystallization. It is also soluble in alcohol. It is soluble in water as well as soluble in alcohol. Aqueous solution of sodium hydroxide is strongly alkaline due to its complete dissociation, because whenever we are going to dissolve in water, it dissociate completely, to form sodium positive ion and hydroxide negative ion. Okay. Okay, everyone.
Yes.
Yes, sir.
Yes. Solution of sodium hydroxide is soapy to touch, means it's slippery to touch. Beta. whenever you are going to like hold soap by your wet hand, so it feels very slippery, right? So it is the nature of alkali, means sodium hydroxide or base beta. It is bitter to taste because it is base. When the concentration solution of sodium hydroxide comes in contact with skin, it breaks down the skin and flesh to the pasty mass. OMG. So it's very dangerous, you can say.
Yes, sir.
Yes. So that's why I told you just keep proper take care while using such chemicals in laboratory, because in higher classes you gonna have chemistry subject and there you will use such chemicals in laboratory. So do take proper precaution while using this. Okay.
So from 11th grade onwards, we will actually be doing the
Yes, yes.
practical
Chemical
in
reaction.
labs, right?
Yes, yes. In chemical laboratory, you have to perform experiment. Beta. We did many. Okay.
Sir.
Yeah. Okay. Now use this in mixing of soap, paper, and viscous rayon. Okay, like artificial silk, you can say. Even organic dye stuff means coloring agent, and many other chemicals are being prepared by using sodium hydroxide. It is used in refining of petroleum and vegetable oils also. In the purification of bauxite is nothing but the ore of aluminum. Ore means the raw material which is obtained after mining and used for extraction of metal. Okay, it's called as beta ore, and the ore of aluminum is called as bauxite. Okay, and its formula is Al2O3 dot H2O. It is bauxite beta. Okay,
Yes, sir.
and it is used for extraction of aluminum. It is a cleansing agent and in washing powder for machines, metal sheets, it is been used. It is too caustic to be used in washing clothes or hands. So it is like used in dilute form. Okay, otherwise it may damage the hands also. Okay,
Sir, but it is
that's why we are not using that washing powder for cleaning hand and washing purpose. We are not using that, right?
yes, sir. Sir, but sodium hydroxide is the main source of soap, right, sir?
Yes, but its concentration is very less. No, no, beta. In we are using salt of like we are using fats and higher acid like oil, you can say, like coconut oil, peanut oil, then even palm oil also, and we are boiling with the sodium hydroxide. So they use salt of sodium hydroxide. That salt of sodium hydroxide, sodium metal we are using, beta, not sodium hydroxide. Okay, yeah, we are using for preparation, but we are using its product. Okay, okay, that process is called as saponification, the process in which soap is formed. Okay, it's called as saponification. Okay, next for mercy, what is written here? Mercerizing cotton. Okay, see, generally cotton, which is like not in the thread form and it's very delicate, it breaks easily. So, in order to provide the strength, okay, and we are treating that cotton with the help of
Sodium hydroxide.
yeah, sodium hydroxide. Okay, next. Next, as an agent in laboratory, so we already reagent in laboratory, we already discussed that. Then in reclaiming the rubber, see, rubber formed from the latex plant, it is not having the very strength, right? That's why we are treating that rubber with the help of sodium hydroxide and sulfur, okay, and other chemicals also, in order to provide a good tensile and elastic property to it. Okay, so here again it is being used. And in preparation of soda lime beta. Okay, sodium hydroxide is used. Okay, everyone.
Yes, sir.
Yeah, so again I want just repeat it beta once. Okay, done beta.
Yes, sir, done, sir.
Everyone done?
Yes, sir.
Okay, next we have plaster of Paris. Okay, it's quite long again, and it is not going to may complete. POP is the last part. In between, we have water of crystallization.
Yes.
Okay, let's discuss that. Okay, now last, but no. Plaster of Paris, we will discuss later on. First, we will discuss water of crystallization. Okay, see, most of the salt they present along with the water molecule. Like we have copper sulfate, CuSO4, copper sulfate. It contains 5H2O along with it, right? So that water molecule present in crystalline structure of the salt, right? Water molecule present in crystalline structure. Crystal, C, what is spelling of crystal?
It's the same before only, sir. CRYSTAL.
Crystalline structure of salts. Okay, the water molecule present in crystalline structure of salt, which is responsible for which is responsible for which is responsible for sometime color, for color. Okay, it's called as water of crystallization.
Sir, what do you mean by responsible for color?
See, you know the blue vitriol,
Yes, sir.
the copper sulfate is blue in color. Okay, that blue color is due to water molecule is present there, beta. If you will heat that, that water of crystallization is going to evaporate and that blue color disappears. Okay, so that blue color is due to the water of crystallization present in crystalline structure of copper sulfate. Okay,
Sir, then for gold, it will be aqua regia, something like that.
no. Aqua regia is something different, beta. It is a solution of concentrated nitric acid and hydrochloric acid. Here, concentrated HNO3 plus concentrated HCl. in 3:1 ratio. Okay, that solution is called as aqua regia, and it has the capacity to corrode the gold also, the gold. Okay.
Yes.
Yes. Okay, now understood what is water of crystallization?
Yes, sir.
Yes. Any doubt, Beta?
No doubt, sir.
Okay. Okay, then we had to go through here now nitric acid and the hydrochloric acid. Their ratio is not 3:, it is 1:3. One part is nitric acid. Okay, so you can write like this: HCl, H2, HNO3, like this, and it is H2, 3:1, means 3 part HCl, 1 part HNO3. Okay, and concentrated one. Okay, it is called as beta aqua regia. Okay. Okay, everyone. 75% HCl, 25% nitric acid. Do reply.
Yes, sir.
Yes. Okay. Let's discuss from the notes now. When crystals of the certain salt are formed, they do so with a definite number of water molecules in their crystalline structure, chemically combined in a definite proportion beta. So, definite number of water molecules are present in their crystalline structure. Okay. So, water of crystallization is the number of water molecule chemically combined to a definite molecular proportion, okay, with the salt in their crystalline state or crystalline structure is called as water of crystallization. And this water is responsible for geometric shape, color, and yeah, the done. Geometry, shape, and color of the crystals. Okay, so it is required like responsible for color, responsible for shape, and geometry of the crystals. Okay, everyone.
Yes, sir.
Yes. So always remember the substance containing water of crystallization is called as hydrous substance, hydrous, okay, or hydrate substance, hydrous or hydrate. This water can be expelled by heating, okay. Then if water is not present in crystalline structure and it has been removed, then it is called as anhydrous beta. It is called as what? Anhydrous. Understood? Hydrous and anhydrous.
Sir,
Yes, beta.
sir, in the remember point once again, sir. My mic and speaker were not working, sir.
Okay, see, if water molecule is present in crystalline structure, then it is called as hydrous or hydrated salt. But if it is heated, that water molecule is being lost. Okay, then it is called as anhydrous or dehydrated salt. Okay.
Yes, sir. Yes.
Yes. Okay, any doubt till here?
No doubt, sir.
Okay. Dhanunjay, any doubt beta?
No, sir.
चलो चेहरा दिखा दो, ठीक है ना? नाम और कैसे? Then who we have next? Dhanunjay. Yuvan Karthik. Sorry. Are you there, Yuvan Karthik? Yuvan Karthik, are you there, beta?
Sir,
Any doubt?
no, sir.
No. Medha, Hanchini,
Yes, sir. No doubt.
any doubt, beta?
No doubt.
Any doubt?
No doubt.
Okay. Then we have start your cameras, everyone. Again, you used to switch off your cameras, beta. I think today itself you got notification from the ma'am.
Yes, sir.
Yes, you have to keep your camera on. I do also like take some time, but what happens, here, sometimes I'm getting like a weak network or network issue. That's why I used to switch my camera on. Otherwise, I had no problem. Okay, so you also have to keep your camera on. Okay, everyone?
Yes, sir.
Yes. Okay. Then we have Veera. Harshit, any doubt, beta?
No, sir.
Okay. Then Dhananjay is done. Monish, any doubt?
No, sir.
Nityashree, any doubt, beta?
No, sir.
Okay.